Hey everyone, I'm going to try to keep this video pretty quick, but I'm going to address a big misconception that came up when I was reading a lot of your replies, your assignments for day 2. You'll remember that this table here shows us when precipitates are formed, or in other words, when solids are formed when these compounds are mixed. Now there was that question at the bottom that asked how this would be helpful in the context of our river water samples. So here's a beaker. Let's say we had some river water in it. We're not looking to see if there's any solids in the river water. I saw that response a lot. We're not trying to see like, well, if there's a solid, then it must be, one of these solids here. That's actually not what we're doing with it. What we can do is we can actually react things. We can put something into our river water to see if it reacts. So let me draw. Let's draw a little dropper. They have these droppers that have let's see, they look kind of like this with a little bulb on the end. And there's going to be some chemical in the dropper. And we're going to add that to our river water sample. And let's say, let me back up for a second, just so you know why I'm adding that. Let's say that we think that there is chloride. Let's say that we think that there is chloride in the river water. Now we know that sodium is always soluble. So it doesn't matter what we add to sodium, it's going to stay dissolved. But that's not exactly the case for chloride, because chloride sometimes isn't soluble. For instance, let's follow this down as we're looking here. Notice that when chloride is reacted with lead and silver, a precipitate forms. And that's because we form a compound. The precipitate in this case is going to be PbCl2, and in this one it's going to be AgCl2. So those are two precipitates that form. Of course, we would need to add a compound that has lead and a compound that has silver. So let's say we do that. Let's say that we add lead nitrate, PbNO3, to our river water. And sure enough, let's say that we get a solid forming. I'm just going to choose a green solid here that's forming and it's falling to the bottom of the beaker. Does that mean, maybe green wasn't a good choice. Let's just, some color other than clear. Does that mean that it's definitely chloride? Well, no, because look, lead forms solids with all of these. So that just tells us that the product or that whatever is in the river water forms a solid with lead. Now let's try a different one. Let's try iron nitrate. Let's say that we reacted iron nitrate, FeNO3, it's iron 3 nitrate in this case, and let's say a solid formed there too. So a solid formed with iron nitrate. Well, iron nitrate only forms solids with these ones, and actually not all of those, these three and this one. So what have we narrowed it down to? Well, it could be any one of these now. So we just determined that there is no chloride in the sample of river water because chloride does not form a solid with iron nitrate. So that's like how you could use this. Now we'd have to react another thing. Now let's react aluminum nitrate. So I'm going to do aluminum nitrate. And let's see, we add some drops to the water, and again, a solid is formed. So now we've narrowed it down to, let's see, solid forming here and here. Well, now that didn't really narrow it down for us, so we still know it's one of these three ions. Let's do magnesium nitrate. Let's say we add magnesium nitrate, but no solid is formed. Okay. Well, magnesium nitrate with these two doesn't form a solid. We've already determined that it can't be this one because that one, sodium chloride, doesn't form a precipitate with aluminum or iron, but we saw that it did. So we have just determined that there is sodium sulfide in the water. Okay? So let me show you another way of showing all of this. We have 3 different compounds that we reacted. And lead. If we reacted these 3 with the river water, and let's say with these results, we got a solid precipitate, a precipitate, a precipitate, and this one would be aqueous. So there was no precipitate. What we're looking for is, with those 3, which ones form a precipitate, a precipitate, a precipitate, and no precipitate. So I'll just circle them as I go through. With lead nitrate, all of these form precipitates. With iron nitrate, all of these form precipitates. With aluminum, all of these ones. And we get no precipitate with magnesium, so I'm looking for these ones. What's the only ion that could be in solution that would cause those results? Well, here's the results that we got. It would have to be sulfide. So now we know that sulfide is in the river water sample. Although, this is a hypothetical that I'm coming up with here, so these aren't actual results. But you need to think about it in terms of using test results to determine what ions are actually in the solution. And this is just one example.